JavaScript arithmetic. We are moving out of Ruby, and we are going to start looking this evening at this lab, which covers some of the basic arithmetic functions in JavaScript and covers some of the basic math functions in JavaScript. This is a really important lab because obviously a lot of what you're going to do in programming is manipulate numbers and do things with numbers. As a liberal arts person myself, math can be scary. You're a scientist, so probably math is not as scary for you as it is for other people, but it can definitely be intimidating for some people, especially with liberal arts backgrounds. But one of our goals tonight is to work through these, to understand what the operators are, to talk about the built-in objects like math and number, and to hopefully solve the lab. Does that sound good?
Cool, yeah.
Awesome. Okay, cool. So what we're going to do tonight is we are going to recognize the limitations of math in JavaScript. We are going to employ operators to perform arithmetic and assign values to variables. We're going to explain what an NaN is, what NaN is. We're going to use built-in objects like math and number to accomplish complex tasks like generating random numbers. We're going to create random numbers tonight. That's awesome.
Woo!
Why are we going to do that? Because math is awesome. Now, JavaScript and Ruby are a little different when it comes to math. JavaScript has only a single all-encompassing number type. Other languages might have other distinct numbers for integers, decimals, etc. With JavaScript, every number is represented as a double precision floating point number, or just called a float.
Okay.
What that means exactly, we're not going to drill down to what that means exactly tonight, but essentially it can create some limitations, some constraints on you if you're looking for absolute precision. So if you're doing complex mathematical algorithms, or you're trying to crunch a lot of numbers for, let's say, a finance company or a hedge fund, you might not want to create that code in JavaScript. JavaScript might not be your data language of choice.
Okay.
Because while it's great for most things, when it comes to like crunching numbers where specificity is the most important thing you're looking for, languages more like Python or R would be more appropriate for, really complex, really, and more so than just complex, but really specific data results that you need, number results that you need. And so here's a couple examples where if you do 0.1 times 0.1, you get back this 0.0100000002, right? Because it's representing it in this floating form, this double precision floating point number. And a similar idea when you get 0.1 plus 0.1 plus 0.1, you get this. And this is actually very similar to when you're doing things like when you're trying to represent 1/3 in the decimal system. You get back, what do you get when you have 1/3 in the decimals?
I can't do math, but 0.333333.
Get that like long string of 0.3s, right?
Yeah, I usually don't do math without a calculator.
Without a calculator, right? And by the way, once you start learning to do math with JavaScript, you end up doing this all the time. Instead of opening your calculator app, you just go into your console in JavaScript.
Use it as a calculator, yeah.
So you just end up like, oh, what is 4 plus 4? Oh yeah, it's 8. It just becomes like your default calculator. As opposed to loading up your calculator app.
You ever do this at the grocery store? Like, hold on, let me get my computer out.
Let me get my laptop out. Let me open the JavaScript console. Let's figure out if that receipt is accurate. That would be the ultimate telltale sign you're a software developer. So you don't really need to worry about that most of the time. But it's a good point to know that all numbers in JavaScript are considered floats, are represented as floats, meaning double precision floating point numbers, which doesn't come up as relevant for you often, but if you ever end up working in a place where the precision of the calculations are most paramount, you probably would not want to do that in JavaScript.
Okay.
So JavaScript uses the same operators that you've seen in Ruby, right? Essentially the same things.
Right.
Plus sign does addition. The subtraction sign does
subtraction.
The asterisk represents multiplication. The slash represents division. And here is our favorite.
Oh, I love that one.
Well, I think we should create a fan club for this one because I love it as well. The modulo, the remainder operator, which does the same thing in JavaScript that it does in Ruby, which is returns remainder when the left number is divided by the right number. So the remainder of 9,001 divided by 42 would be 13. This one, we didn't cover this in previous Ruby exercises, but this is, I'll give you double stars if you can pronounce that word.
Exponentiation?
That's awesome. I was struggling with pronouncing that word. Exponentiation operator. It's too many vowels in that word. Too many.
That is that's one heck of a word.
One heck of a word. So the exponentiation operator returns the left number raised to the power of the right number. So 2 to the power of 8 would be 256. And we can even try some of these out in our JavaScript console. I don't know why it's acting a little slow right now. I'm not sure. Here we go. So 8 to the power of 4 is 4,090.
Ooh, yeah, see?
Or, 4 divided by 2 would be 2. 4 modulo 2 would be 0. And you can even do things like this, right? You can do let number 1 equal 8 exponentiation to the power of 4, and then if you call number 1, you get.
It would give you the answer.
You can do number 1 divided by 4, which gives you 1,024. That's pretty
wow,
cool.
That's cool.
And then you could even have more fun. Let number 2 equal that, and then you do number 2. 1,024, and then number 2 could be divided. What could be divided before? But let's do multiplied by 987, 6, 5, 4, 3, 2, 1, and you get. So you can.
You won the lottery there.
You won the lottery! Congratulations! But you can really play in your console with all these functions and see how they work in real time. The same way that you would use IRB and Ruby, you can do your user console as a real live sandbox to play with JavaScript functions. Now, this is actually a really important point here. What gets operated on first? You might not think this matters so much, but it really does matter because sometimes when you're trying to find out what's the issue, why is your code not working, it might be because you're expecting a different result, but you forgot the order of what gets operated on first, which is an easy thing to forget, and people forget that often. So even though in the lab it says, this is the familiar order of operations that's taught in grade school math class, apparently a lot of us forget what's taught in grade school math class, including myself, because it's easy to forget that things within parentheses have the highest priority, exponentiation is second, then multiplication, division, remainder, and finally addition and subtraction.
See, and remainder isn't something you learned in high school, I don't think.
I don't
remember that.
Maybe in some schools they did that.
Not mine.
Certainly not in mine either. And so, for example, if you look at example on line number 1 here, you have a 2 minus 2 remainder of the 2 minus 2, the remainder of divided by 2 plus 2, divided by 2 exponentiation to the power of 2 times 2, which gives you a value of 3. And that's because what's happening first is the exponentiation is happening, the power to the power of.
Right.
Then the multiplication is happening, and then the division is happening, and then the modulo is happening, and then the addition and subtraction is happening.
Yes, I feel like we're doing the ACT test right now, or the SATs.
We basically are. Essentially that's what we're doing right now. So if we actually run this in our console, wait for the console to load. There we go. Right, we got.
Woo!
Cool.
I like it better in there. You do it, console.
You do it, console. And here we have the highest priority given, which is things in parentheses.
Yeah.
That's like a super good thing to know if you're ever on Jeopardy, and they ask you, in this language, in this thing, mathematical functions are operated on first, and you're like, what is a parentheses? And you would win the game. And it's also good to know for any quizzes you might ever take in life on programming, because people sometimes forget that things in parentheses are operated on first. Does that kind of make sense?
Oh, it totally makes sense.
Okay,
yeah.
Cool. Um, the next fun part of the wonderful world of math is incrementing and can you pronounce this word?
Decrementing.
Decrementing. Incrementing and decreasing.
Yeah.
Sounds more English-like. Incrementing and decrementing. And that's done with the double plus. Have you used that before?
Yeah, I have. And then I've used the plus equals, which adds in the variable, right?
Exactly. That's exactly right. So
Yeah.
here is something really important here is to understand the difference between where you place this incrementer. If you place it before the variable or after the variable.
Okay.
It's really important to know because it doesn't actually change the ultimate value. So if you place it after your ultimate value will be 1. If you place it before, your ultimate value will be 1. But look at what it returns while it's executing. So while it's executing it, when you have the incrementer after, the return value in the midst of execution is 0, because that's what it was initially defined as. And then your final return value is 1. Whereas if it's placed before the variable name, your return value in the midst of executing it is 1, and your return value once it's finished is also 1. Because this actually just syntactically makes sense that when it's placed after, the variable's value is returned first and then incremented.
Right.
Placed before, the variable's value is incremented first and then returned.
That makes sense.
Yeah, it actually it fits logically. Like you can see that. So like let number equal 3. Cool. And then we see number is 3, and then plus number is 4. But let's see.
Number plus would be 3.
Well, number plus would be 3.
Oh, I thought it would be 3.
So at the end, the return result is going to be the same no matter what. It's in the midst of the execution code that it becomes 0, or it becomes whether it changes while it's executing or after.
Okay, gotcha.
Yeah. Okay. And then it's the exact same thing with decrementing. The exact same principle applies where you place it before or after in your code.
Ooh,
And
look at all those.
Right?
Yeah, they've added a lot to it.
You've only seen this one before.
Right, I haven't seen all those.
You've only seen plus equal. You haven't seen minus equal, multiply equal, divide equal, modulo equal, power to the power of equal, right?
I didn't even know you could do all that.
You can imagine they all do the exact same thing that plus equal does, except for its own operator.
So that one's going to increment by 10?
This one will add 10, yeah.
So 10, 20, 30.
Right. And this one will subtract 2 and then give you the return value, which will be 8.
8, and then it would keep doing it.
Yeah, this one will times by 4, and it'll return 32. And this one will divide 32 by 2 and give you 16. And this one will give the remainder of 16 divided by 6, which would be 4. And this one will take 4 to the power of 3, which is 64.
Wow. That's pretty cool.
Yeah, it's actually pretty cool. This is also really good to know, the nan. JavaScript tries to return a value for every operation, but sometimes what you're asking it to return is just not going to happen. And so if something's broken it and it's returning and it can't calculate, it will return to you this following keyword or symbol or just an acronym, actually, NAN. And NAN stands for?
Not a number, but I was going to go with delicious bread. No.
Exactly. Right. You can eat it with your dosas.
Or your mango chutney.
Mango chutney. Oh, that sounds delicious, actually. And it's basically JavaScript is saying, no, you can't do that. You can, it's not going to, that's not a number. Let's see if we can get that to happen in the console somehow. Let's have fun with that for a second.
I think if you add 1 to a string,
Let's see what happens.
you might be able to get a non. Oh no, I put it together.
Do you know why that happened, by the way? So what we just did here is 1 plus hello, and I put them together as a string of 1 hello. So why did it do that?
I'm not sure.
This is both the blessing and the curse of JavaScript. JavaScript wants to help you so much. It wants to be really, really helpful. But in its attempt to be really helpful, sometimes it ends up causing more harm than help.
Yeah, because it doesn't tell you, hey, you probably shouldn't add those things together.
Exactly, because what JavaScript says, oh, the developer probably meant that 1 as a string. And probably what you probably meant to do is this. That's what it interprets it as.
Yeah.
So when you do that, you get 1 hello, but when it sees this, it's just assuming you missed the quotation marks.
Oh man, JavaScript's assumes. That's not good.
It assumes a lot of things, and it does so in an attempt to help you, but sometimes that help is not always so helpful, especially when you're trying to actually say, no, I want to do these 2 things, and I want to see the error, and it's not going to give you the error because it's going to keep on returning it together as if it was 2 strings you want to add together. So that's really interesting. So let's see the example they did. So well, counter's not defined, so that's the problem. Like counter, okay. There we go, right?
Okay, yeah.
So you can define a variable without any value. So counter just is not a number. That's the only value it has. And so if you try to increment counter, you're going to get not a number, right? You're going to NaN because it's not actually. Right. But if you try to do counter plus 2, also not a number, right? That's cool. 2 plus counter, just to make sure it works both ways, not a number. 2 plus counter, look at that.
Oh, that's pretty funny.
Isn't that funny?
I did not expect that.
Because if it sees you're trying to add 2 things that are different to each other, it is assuming you meant them to be the same thing.
It's like, we got to do this no matter what.
Yeah, exactly. And it'll force them together. Pretty funny.
That's good luck, Charlie. I love that show.
So there's actually a couple built-in objects that JavaScript provides you that you can reference anywhere in your code. I keep on closing the JavaScript console, but I should just keep it open because I'm using it all the time here. But like, for example, if we just type in math, we get back the whole object of math.
Yeah, and like, hey, you want to do any of this?
You see all the things here with little carrots?
Yeah.
These are all the functions you can call on math.
There's a million.
There's a million, and they're awesome. So, like, here's one.
Cosine. I see cosine.
And you can see all the different details around it, and all the fun stuff you can call in math. And if you type in number, you get the exact, well, you see the number is an object. It doesn't have a lot of built-in, it doesn't have built-in functions, according to this. But it is an object, right? Where math has built-in functions, all these wonderful, beautiful functions that you can call on them. So we're actually going to take a look at some of them. So, like, for example, number is integer. What do you think is integer does? Well, it says right here.
Makes a string an integer, maybe? Checks whether the provided argument is an integer. Okay.
It's integer. So,
I just feel like it needs a question mark because I'm so used to Ruby.
Because Ruby would put a question mark, as opposed to this would be false. And by the way, just like for Ruby, the go-to guide of looking things up would be the Ruby doc online. For JavaScript, the place to go would be here, which would be the MVN web docs. Part of Mozilla, developer.mozilla.org. And here you can look up basically anything in the universe of JavaScript. So, for example, on this page, we're looking at the math function, the math object, not math function, but we can look all about the math object. And we can see the properties that it has. Like, for example, math.square root 2, right? Square root of 2, approximately 1.414, good to know. Math.pi, ratio of the circumference of a circle to its diameter, approximately 3.14159. See all the methods you can call. So just like we looked in our console, and we had all these fun methods, here we get a little descriptions for them. So like math.abs with an argument returns the absolute value of the number you provide as the argument.
I'm looking at it down there at that ACOSH.
Returns the hyperbolic cosine of an. I don't even know what that means.
I know cosine is something in geometry, but I don't know exactly what it was anymore. So it's an arc cosine, whatever the heck that is. Woo! I'm so happy I didn't major in math.
Cosine of x is defined as the inverse cosine function of x when -1 is something x.
So it has something to do with x and y axis. See, like
math,
I don't.
Again, is not my specialty.
Me either. I'm like, woo, too much.
But there's some functions here which you could end up using a lot.
Yeah, just not that one.
You might not end up using that a lot, but you never know. You might end up in a place where you end up using that a lot. But
I hope not.
Yeah, exactly. So math.ceil returns the smallest integer greater than or equal to a number.
Okay.
So let's try that for a second. And give it 105.4, we get back 106. Because math.ceil returns the smallest integer greater than or equal to a number. Greater than or equal to a number, right?
And then if you did floor,
get back 105.
Right.
And that, again, the language makes sense for what it's doing. Because you're giving the ceiling and you're asking for the ceiling in one and you're asking for the floor in the other one.
Yeah, that makes sense.
And here it is. Math.floor returns a large integer less than or equal to a number.
Round.
Math.max returns the largest of 0 or more numbers. Math.min does the exact opposite. Math.pow with two arguments, x or y, returns base to the exponent power that is base exponent. Math.random returns a pseudo-random number between 0 and 1.
That's cool. I think I've used that somewhere.
We actually are probably going to use it tonight.
Cool.
Math.square root returns the positive square root of a number. Math.trunc returns the integral part of the number x, removing any fractional digits. And we're not going to get here tonight, but one of the powerful things about JavaScript, and in fact many languages, but it exists in JavaScript as well, is that you can actually extend objects by creating your own methods, your own functions on those objects, and you create them as prototypal objects, prototypal functions. So you can actually create your own, and then in addition to all the ones here that are built in, if you really want to be a math geek, you can create your own math functions here, do your own mathematical logic, whatever that might be. We're not going to get into that tonight, though.
Thank goodness.
So number dot is integer, checks whether the argument is an integer. Number dot is finite, checks whether the provided argument is finite. So 9001 is a finite number.
Unlike infinity.
Infinity to infinity and beyond.
Yeah.
Is not finite, right? It's false. Number dot is nan, checks whether the provided argument is not a number. So is 10 not a number? No, it's false. Is undefined not a number? No, undefined is not. It's false. Is not a number not a number? It is true. Not a number is not a number.
I think that's my favorite one so
far. A really helpful one, by the way. Parse int accepts a string as its first argument and parses it as an integer.
I've used that, but I've used it different.
Well, it's really cool and it's really helpful. So, so load again. Okay. So like, let's see, numbers. I have no idea this will work. We're going to see if this will work. We're going to have fun here.
Okay. I like having fun.
It works, right?
Oh my goodness.
we put in for the value of parsin, for the argument, within parsin, we put in the variable that we created of text, and text was equal to a string of 500, not the number 500. And we asked it to convert the string of 500 into an integer of 500. And the second argument of this is the base that should be used in parsing, whether 2 for binary or 10 for a decimal. So if we put in 2 here, not a number, because that's interesting. So let's try this with, we get back 4. So it's interesting. It seems like you can't use the variable name to do that, which is in itself. So
That's
2
weird.
is the binary base and 10 is the decimal base. More often than not, you're probably going to want to stick to the 10 as decimal base. Now, what if we would try to do this without giving a second argument? Do you think it would work?
Probably not.
Let's see. It works.
It must have assumed something, like
It
to the
assumes
first
that
power.
don't provide a second argument. It assumes that the second argument you want is
1.
well, no, because it gave us 500, which is what happens when you use 10
Oh, I thought it did the 1.
base. So it assumes if you don't provide a second argument, it assumes that you as a developer want to return the integer as a decimal number, not as a binary number. Because more often than not, in development, you're going to want to return the number as a decimal, as a float, and not as a binary number.
That makes sense.
Right. And it even says here the second argument is optional. These are provided to avoid confusion. Okay. Parse float only accepts a single argument. The string should parse into a floating point number. So this does exactly what you would think it does. And then you would call it, and you would just get back, as opposed to that very long string. And you see how it actually truncated it as well?
Yeah.
That's interesting. It truncates it for you too. So that's sort of some of the basic functions within the number object. And then in the math object, the big ones you end up using a lot is math. And we just looked at them: math.ceil, math.floor, math.round. And they do exactly as they sound, which is phenomenal.
Yeah.
Is math.round, which is one we didn't look at, rounds the number either up or down to whichever is nearest. So
Okay.
math.round.
Ceiling's up, floor's down, and math is whichever one's closest.
Exactly. Right? Pretty easy.
Yeah.
And math.max, max.min will take an argument of numbers and return to you the highest one for math.max and the lowest one for math.min. And math.random does also exactly what you think. Let super secret password equal math.random.
Ooh.
And then if we type in super
Secret password.
that's our super secret password.
That's our super secret weird password that we would never remember.
We would never remember in our lifetime, but it's there. And every time
I wonder if people that hack into stuff, like hack into your password and stuff, are doing that random
maybe
password
they are.
generator kind of thing.
I actually had a whole conversation with somebody recently about how this is ultimately pseudo-random. It's not purely random. And there are actually ways of predicting the outcome of running math.random, even though it seems like it's random, but it's actually it's pseudo-random. And again, a lot of that is beyond the scope for tonight and maybe beyond my own scope, but that itself is just an interesting thing. And you can actually combine functions in math. So if we take a look at this one.
It's going to do whatever's in the parentheses first anyway, right?
Yeah, exactly. That's exactly right. So within the parentheses, we're asking it for a math.random between an integer between 1 and 10, right?
Okay.
And then we want to call math.floor on the result of that. And what does .floor do?
Math.floor rounds it down.
Exactly. So we want to take a random number, because the random number we're going to get is something like this, right?
Mm-hmm.
So we want to take that random number, we want to floor it. and then we want to add 1 to it.
I feel like we're wrestling it. We floored it.
We want to floor it, right? We want to take it down to the ground, to the mat.
Yeah, to the mat.
So the result of that would be a whole number that would be essentially random, right? Because we're going to take a random number, within the 1 to 10. We're going to then floor it, and we're going to add 1 to that, which is kind of cool.
Yeah, that's awesome.
Yeah. So that, and we combine 2 separate math functions, within the order of operating first within the parentheses and then outside the parentheses. Cool. So now let's actually work on the lab itself.
Okay.
So we have just joined the Flatbook team. Yay, us. And we have
what a name.
We have our first assignments as members of the Flatbook team. So when Flatbook first started, they assigned ID numbers sequentially in the users. The first user got an ID number of 1, the second got an ID number of 2, etc. But now that Flatbook encompasses every human being on the planet, they have to create IDs that are a little larger. So now what they want to do is they want to have every ID start with 1,000,000,001 as opposed to 1. But what do we do with the original IDs, which started with 1, only 1, 2, or 3? We have to create a new variable called new ID that adds 1,000,000,000 to the value of
old
the
ID. Huh.
So how do we do that? So let's open up our ID, handy dandy browser IDE, and let's take a look here. So first of all, let's take a look at our test. And this is a test. This is a test not in RSpec anymore. We're out of Ruby, right? This is written in Mocha, which is a JavaScript testing suite. And it looks a little different than a RSpec test, but it also has a lot in common. So it should be understandable, even though it's slightly different than what we might have been used to. So what are we doing? Describe new ID. It's a function. New ID is going to be a function. And what is it going to do? It's going to convert IDs from the old style to the new style. And what's it going to do? It expects the new ID to equal 1,000,000,000 plus old ID.
Right.
That's what it's expecting. So let's take a look at our handy-dandy JavaScript file here. Variables defined in the test suite already for you is old ID and current age. You should not try to redefine any of the above variables. So we already have provided to us as part of the test suite the old ID and a current age, which will come in handy in just a couple minutes. So what we want to do here is we want to create a new variable called new ID. Let's just go back down here. We want to create a new variable called, where were we here? Here we go.
Yeah.
Called new ID that's going to take in the value of old ID and add 1,000,000,000 to it. So how do we do that?
New ID equals, maybe?
Well, how do we create a variable in JavaScript? In Ruby, you create a variable by just naming it, right?
Yeah.
But in JavaScript, we do that a little differently.
I don't know.
we need to use keywords that let the code know that we are assigning a variable right now. We're creating a variable. So we have a couple options in JavaScript ES6, in the newest iteration of JavaScript. We can use let.
Oh, let. Oh, I remember let now.
Use
it's been a while.
Do we know what the difference between let and const is?
The constant you can't change ever. They're like permanent.
Const should not change. If you try and change the value of const, you'll get back an error.
Right. So we want to let.
And by the way, let and const as the variable declaring keywords is really like a new phenomenon in JavaScript. For all the history of JavaScript before this point, the way you would create a new variable would be this.
Oh, very. Yeah.
But now that's deprecated. It still exists. You could still do this. But if you do that, you will not make a lot of friends in the JavaScript community.
And they'll make fun of you.
They'll make fun of you.
They won't sit at you at the lunch table.
Exactly. And part of the problem with VAR is that variables defined with VAR are hoisted within your code. There is variable hoisting that happens. Let's see if we can find a handy dandy thing to talk about that for a second.
Good evening, Ben. I love that. What are you going to focus on today? Sorry. Just looking at your
My little dashboard, yeah. By the way, it's a
yeah,
great,
that's cool.
which is our greatest glory is not in never failing, but in rising up every time we fail by Ralph Waldo Emerson.
Does that change every day?
It does.
You get like a new
And you
quote?
get a different background every day as well.
Oh, you do? What is this?
It's pretty cool. It's called the Momentum Dashboard.
Momentum.
And you can, great work. Okay, that's what's fun about it. Okay, so JavaScript hoisting. What is JavaScript hoisting? JavaScript hoisting is JavaScript's default behavior of moving declarations to the top, which gets really confusing because, so here is, let's say, an example that's provided on this website where you get x is equal to 5 at the very top of your code, and then you want to find something within your website by its ID of demo, and you want to set the HTML of that thing to x, and then you create the variable x down here. This creating of a variable down here, when the code is executed, actually moves magically up here.
Huh.
That's really confusing.
Yeah, it is weird.
That happens when you use
VAR. Yeah.
it does not happen when you use let. So it's a great way to not make yourself confused and your head to spin. So we want to create a variable called new ID. We want it to do what? We want it to take in the old ID and do what to it?
Add, right? A million.
A billion.
Or a billion. I'm like, a lot.
I'll copy and paste this number because I'm not going to pretend to type in all this.
Thank you. That's a lot of zeros. Whew.
That's what we want to do, right?
Yeah.
And it's good practice, by the way, to always put a semicolon after every block of code in JavaScript. After every full thought-out sentence in JavaScript, put a semicolon.
Okay.
It's a way of saying you're done with that thing and you're moving on to your next thing.
It's kind of like a period in a sentence.
Kind of like a period in a sentence.
You don't have run-on code.
And it's like good practice to get into the habit of doing that.
Okay.
Is running the test.
Oh. So why is it telling us little clues back there? As you write your code in index.js, save your work often.
They probably put that, the developers of these tests probably put that in there to be helpful to you.
Like a little hint. Here's a little hint while you wait. Feels like we have a endless loop. There it went.
Look, that's interesting. Actually, I think it might be even different. So let's run that again. Navigate to this thing in your browser to run the test suite. Cool, let's navigate.
Okay.
Cool. So here's our test results.
Okay.
We have successfully created a new ID that converted the IDs from the old style to the new style. We successfully did that. That's pretty cool. We have not done these yet, right? We still got quite a bit of work to do ahead.
So that's what Mocha looks like?
That's your test results.
Wow, that is so weird looking, but I like it.
And take a look at this. So,
I haven't seen Mocha before.
You can click on a specific test and just drill down and look at how the test is structured. So age is valid test contains true when the value in current age is a valid integer. So it wants a Boolean of true when the value in current age is a valid integer. And you can even click there and you can see the actual test code. So if current age is integer, expect age is valid to be true. Else expect age is valid to be false. And we need to invoke number is integer function. Okay. Expect spy number is integer called once to be true. Whenever you see the spy word in Mocha, that's spy is used as a way to pry into your code.
So it's kind of like pry.
Yeah. It's looking to see that you have used that function. This test specifically wants you to use the is integer function in the number object. Called once to be true. So let's go back here. Okay, where were we? We were here. So now we need to do that. So let's take a look at the test description. During the sign-up process, we require new users to provide their age. However, the junior developer tasked with creating the sign-up form forgot to validate that the user had entered an integer. So we have a lot of accounts floating around with weird ages, like 21.7 or 9.5, or that's just how like maybe every one of their user is 6 years old and describes their age as 6 3/4. You know, we'd like you to help us identify which users need to be prompted to re-enter their age. So we got to create a variable called age is valid. How do we create variables again? You still there? You still here? I think you're still there. It says you're still there. So the way that we create again, of course, is using a let, and we want to do age is valid. And we wanted to check whether the value in current age is a valid integer. Let's just see if you're still there. Hey, you still with me? Okay, so I'm going to assume you're still with me. So we're going to wrap this up together. So age is, you're definitely not with me right now. So there was an internet connectivity issue. We're back. So let me share this screen again. And we are going to continue solving this lab together. So we need to create an age is valid variable that checks whether the value in current age is a valid integer. So what we have to do is, we don't need to declare current age because as it says here, it's already existing in our test suite. We need to see if number is, how do we do this again? Number is integer. And what are we checking for? Current age. And let's see if our test suite likes that. It looks like we did that one. Fantastic. We also then need to move on, and we need a way to randomly select a user by their ID number. As you know, we have millions of active users on Flatbook, but since this is your first assignment, we'll limit the testing pool to 20 users with IDs between 1,000,001 and 1,020,000. So we need to create 3 variables: random number, which should contain a randomly generated number between 0 and 20, random integer, which should take the value in random number and round it down to the nearest integer, and random user ID, which should convert random integer into a valid ID number, an integer between 1,000,001 and 1,020,000. So let's create random number first. Let random number equal, so we need to create a random number, so how might we do that? Math.random, which again produces a random number, but we need to give it a value of what we want it to produce between. So math.random up to, exclusive of, but up to 20. Hello, welcome back. So random number here produces, welcome back. Random number produces math.random, produces a random number between 1 and up to 20. Random integer will be our next one, a random user ID, which should convert random integer. So we're going to start with random integer. Random integer, which should convert, which is a valid ID number, an integer between 1,000,001 and 1,020,000. That means we want to take that random number and we want to floor it, right? And what do we want to floor? The random number.
I just want to let you know I'm back.
Welcome back. Nice
I had
to
to reboot the computer.
So what we've done so far is we've created an age is valid variable, which all it
Okay.
does on line 11 is it checks whether the number is an integer, the current.
Okay.
We have created a random number variable, which holds a random number between 1 and up to 20. We have created a random integer, which takes that random number and floors it like a wrestling match. And the last thing we need to do is convert that random integer into a valid ID number, which, as we know, the IDs now start from 1 billion. So we need to take the random integer and we need to convert it into a random user ID. So that's our last variable. So somehow we need to take random integer and convert it into a valid ID number, which would be that number plus 1,000,000,001.
Okay.
So that should be pretty explanatory, self-explanatory. Random integer plus that long number. And let's see what happens. And by the way, we've solved all the labs, but by
Okay, good.
solve the labs every time you save your code. So if we would comment this out and save, it automatically runs your test suite again.
Okay.
You don't have to, as opposed to Ruby, when you're running Ruby tests, you type rspec or learn each time in the terminal. Here, you just have to save.
Oh, okay.
And it will run it again for you. It automatically updates your browser with your results. So here we've now passed all of our tests, and the result of all of this is that we are now super math ninjas with JavaScript powers. That
Cool.
is awesome. That is what we are now. We are math ninjas with JavaScript powers. And let's just see if this works in our Mocha tests here. If we would put in debugger, and we would open up our console. Let's run it again. Yes, perfect. So if we remember in Ruby, there's pry, right?
Mm-hmm. Debugger's the JavaScript version.
Debugger. And debugger does the same frozen in time thing. So when you run debugger in your browser, the first thing it'll show you is where you put your debugger. It's in between these new ID and age is valid, right? And you can actually take a look at your stuff by literally just putting your mouse over it gives you the value. So here, the value of new ID, once we've done this mathematical work here, is this 1,000,044,000. Which is really cool.
Yeah, that's awesome.
It's not going to give you the values here yet because we put the debugger before these are executed, right?
Right, so the debugger stops it just like pry, huh?
Exactly. And if we go to console, we can actually type in new ID and get back the value and play with it as if we're live.
So originally they were 44.
Yes, in the test suite.
Cool.
Cool, right? And so we can play in the console with the variables we created when we run debugger as if we're in the midst of a program here, and somehow our JavaScript console knows about the variables that we have in our code because we've used debugger and given it that magic power. And when we want to continue running our code, we just press the little arrow here and it'll continue.